In every plan assessed, the Energy Services team carefully performs a comprehensive analysis of both the supply and demand side of a compressed air system. This is to determine how one impacts the other while searching for any potential areas for improvement. Ultimately, the goal of each recommendation in this report will be to directly or indirectly reduce energy consumption as it relates to the manner in which each compressor consumes power. The Energy Services team performs a complete system-wide analysis focusing on every detail of the customer's pneumatic process. Gathering all supply-side equipment information, identifying infrastructure issues, and general layout concerns that can lead to pressure loss are just a fraction of the steps taken in a fruitful energy campaign. The flow, pressure, and compressor power consumption studies are one of the most important portions of an air assessment. Gathering the necessary information from the supply side of the compressed air system allows the Energy Services team to determine how the compressors are configured and operating to meet the plant's demands. The Energy Services team measures the total flow from all operating compressors in the mainline header prior to the air branching off into the plant. This data is used to identify the plant's demands and to develop trends based on the facility's production schedule. The pressure is gathered in the same time intervals as the flow in order to help develop trends and identify any surges that may occur based on compressors' pressure settings and how they react to the demands of the facility. Clamp-style amp meters are attached to electrical circuits on all operating compressors in order to gather the individual power consumption for each unit. This data is coupled with the flow and pressure data to provide a complete understanding of the true power consumption for each compressor in relation to the flow that the unit is producing. This data is invaluable as different compressor control methods become inefficient at varying loads. For every industry, there is a certain level of dry air required for the process that is being performed. Based on the dryer type, dew point levels can vary from -100 to +50 degrees Fahrenheit. Over time, the dryer's functionality can deteriorate for a multitude of reasons. Allowing the dew point to erode beyond the design specifications can result in passing of bulk water downstream to the pneumatic components, which can have negative effects on the process and the components themselves. Monitoring the dew point levels downstream of the operating dryers helps to determine whether or not the dryers are working to standard. The necessity for the overall quality of the compressed air varies from industry to industry. Regardless of the need for clean air in terms of the process, achieving the true life of a pneumatic component is extremely dependent on air purity. Passing oil, water, and contaminants downstream can have negative effects on almost any pneumatic component. Compressors are all set to operate at a specific pressure or within a defined pressure band. There is some level of pressure loss expected across the supply-side equipment. Piping design and effective storage are two of the most important variables in compressed air efficiency. Poorly designed systems increase velocity, friction loss, and restrict flow, all of which results in pressure drop and energy loss. Leaks are the thieves in every compressed air system and typically account for 10 to 20% of the compressed air usage. The Energy Services team utilizes an ultrasonic leak detector to identify leaks. This detector focuses on the frequency level that compressed gas creates. We document, quantify, and tag each and every leak. Airflow, artificial demand, and excessive pressure are all forms of inappropriate uses of compressed air. There are processes that can benefit by using a different technology to reduce energy consumption. The video above serves as a guideline for the installation of the ball valve assembly. It's used for mounting and installation of the flow meter and pressure sensor. The flow and pressure test is the most vital piece of information of the assessment, and it allows the team to accurately calculate the energy cost of running the compressors. And this concludes our training on what the Energy Services team does in order to save money on a compressed air system.